What's going on? So this is Arunava, and in this video I'm gonna make a quick go through over the paper on neural algorithm of artistic style. Now this paper is the first paper that was published that uses deep learning to perform style transfer. To start with, let's just discuss what is style transfer, right? Now style transfer is basically what happens is there is a style image, say an image of Starry Night, right? The image of Starry Night, and there is a content image, say this image that is currently shown on the frame, and you want to copy the style of style of Starry Night to the content image, that is the image that is currently on the screen, or any image of your choice, or an image of a selfie of yours, right? So that style is to be copied to the content image, right? So, and this is the first paper that shows how to perform style transfer very well on using deep learning. Now let's just make a quick walkthrough over how CNNs see, right? So what CNNs do is basically CNNs trained on image classification tasks. If you are if you are training a CNN on face recognition models, to recognize faces, then what will happen is the lower levels of the CNN will capture the low-level features such as edges, and these low-level features will then get combined to form high-level features such as noses, eyes, and mouth. And then even in the higher layers, what will happen is those features will get combined to form faces, right? So this is in general how CNNs see. So with that in mind, what happens is in in our style transfer, in our and that is in particular this paper by Gatys, is that they use a pre-trained VGG19, that is a 19 layer long VGG network to which is pre-trained on the ImageNet dataset, to capture the representations of the style and content images from the intermediate layers of the VGG19. So the input image, that is the style image, not the input image, the style image is passed into the VGG19 network, and it is a non-trainable, so it is fixed. It is a fixed VGG9 network, and the input image is that is the style image is passed, and its representations are taken out from the intermediate layers. And same happens for the content image. The content image is passed into the VGG9 network, and its representations are taken out from the intermediate layers, and these two representations are then stored, and these two representations are then used to calculate the style and content losses and then optimize the input image. So let's talk about what is the input image, and let's make a brief go through about how the model works. So in general, how the model works is basically the input image is the content image. We start with the content image and pass it to the VGG19 network, right? And we take out the representations from the same layers that we take out, the same layers from where we take out the style representations and content representations of the style and content image. And these representations are then used to calculate the losses. So let's just take a quick look at what is the functions of losses. And here, over here, you can see that the style representations are taken out from the intermediate layers, and what you can generally see over here is that from the lower layers, the style is not that well preserved, but when you combine the features, style features from like a few layers, then it like captures the style, the texture, but not the global arrangement of the content in the style image. And in case of the content image, what happens is what happens is that in this image over here, you can see that it captures the global, it captures the objects in the image, but not exactly the pixel values, the detailed pixel values that is in the content image, right? So these are the representations of the style and content images. And let's just look at the losses, the loss functions that are used to calculate the losses with respect to the style and content representations. Okay, so this is the loss function that is used to calculate the content loss. So it's basically a simple Euclidean norm, and you basically take the two matrices and you subtract them and you square them and then you half them, right? Basic Euclidean norm. And in case of the style loss, what happens is you calculate something which is something called gram matrix. So for the style representations, so in case of in case when you're implementing the implementing this algorithm in paper from the paper, then you what you do is basically you have a gram matrix. You for the style representations, for the I mean the target style representations, you calculate the gram matrices, and for the and then for the style representations that for in each epoch, you calculate their gram matrix, and then you compare those gram matrix using this formula, which is given on this paper, right? And one of the interesting things that this paper shows is that the style and content of the images are can be varied independently. That is using this formula over here. So there is as you can see, the content loss is preceded by a factor called alpha, and the style loss is preceded by a factor called beta. So you can change, you can vary the alpha and beta to get appropriate representations, appropriate weightage of style or content on the final output image. And coming to some of the some of the results that is shown that you can get from this paper is over here. Yeah, there you go. So this is a picture of and yes, this is a picture of this is the content image, and this is the style image, this small ones, the style image, and you basically combine them to get the output image, which looks like this. And the same is the case for every each one of these pictures. Now, a few drawbacks for this method that is particularly proposed is that this particular approach is very computationally expensive, because for each inference, basically, whenever you're trying to take a get an output image that is combine a style and content together, you're trying to solve an optimization problem. So you have you have the pre-trained VGG19, then you have to pass the style and content images to get the representations, and then you have to pass you have to start with the content image and optimize that image again and again with like epoch after epoch to like get the perfect representation of the of a perfect combination of the style image and the content of the content image, right? So that is like an optimization problem that is very expensive. So basically you cannot you cannot use this algorithm to perform real-time style transfer. But one of the advantages of this algorithm is basically it can perform arbitrary style transfer. So given any style and given any image, it can combine both of them to perform take the arbitrary style and change the content image to have that arbitrary style. And this is not possible in a few of the researches that took place after this, like the one by Johnson et al. Yeah, perceptual losses for real-time style transfer and super resolution. So in that paper, what happens is basically they have shown, and I'm just go a quick walkthrough, is that they train image transformation network, and this image transformation network is actually trying to solve the optimization problem that is proposed by Gatys, that is this paper. Okay, and those networks are there is basically one network per style. So you train one network per style, and then at inference time you can just put a content image, and then you can just make it a feed forward. There's a feed forward network, and then you can get your output image. So those networks, those image transformation networks, work in real time, but but they don't work for arbitrary style transfer. There is like one network for each style. So basically to have another style, you have to you have to train another network, right? So that was all. And be sure to go through this paper. I will have this paper linked in the description section below, and it's a very interesting read, and it's a very simple read, by the way. So yeah, that is all, and I'll be sharing. So I've started working on style transfer, and I'll be sharing a bit of on style transfer. Rather, I'm working on a project using style transfer using TensorFlow. So I'll be sharing about that. Yeah. So, and have a nice day, right? Bye bye. See ya.